Good afternoon. My name is Carrelo Rivera, and today I am giving a presentation on thermal energy, heat, and temperature. To many, these terms have the same meaning, but with a different visual. Tomato, tomato, right? Wrong. Knowing the difference between thermal energy, heat, and temperature is not only beneficial, but can apply to everyday situations. Thermal energy is defined here as energy possessed within the object or system due to movement of the particles within the object or system. Now, trust me, when I read that, it definitely threw me off. Thermal energy is commonly thought of as heat, but there is a difference between them. Now, in this second definition of thermal energy, it states, thermal energy is defined as the total kinetic energy possessed by a particular system or the total speeds and movements of molecules of a particular object. With these two definitions and my own research, I formed my own interpretation of thermal energy. For me, it is very simple. Thermal energy is energy within an object or a system due to the movement of particles within. If you are lost and shaking your head already, please bear with me. In order to understand a concept, taking the extra time to go past a few definitions can be fulfilling. As previously mentioned, thermal energy has to do with motion. Therefore, thermal energy is a type of kinetic energy. If you're scratching your heads thinking where you know that from, let me refresh your mind from your middle school years. Kinetic energy is energy possessed by being in motion. Simply put, when you, an object, or anything, is in motion, kinetic energy is a force generated because you are moving. The movement of the particles within an object or system results in an internal temperature that is recorded and measurable. Now these particles, the faster they go within this object or system, the higher the temperature will read. Thermal energy has the ability to move from one object or system to another. When this takes place, it happens in the form of heat. Oh, I almost forgot. The image below illustrates a common type of thermal energy, known as solar thermal energy, in which energy is transferred through electromagnetic waves. Of course, this picture is of our sun. Now, the next topic, of course, is heat. Hopefully, after this presentation, a clear distinction between thermal energy and heat can be made. With the topic of heat, we once again face multiple definitions and interpretations. But first, in the image presented in front of you, we have a pot being heated by the burner on the stove. Heat is transferred from the burner to the pot at the point of direct contact. This type of transfer of heat is known as conduction. Now, another definition is from the Khan Academy that states, heat is the thermal energy that is transferred from one region to another, while thermal energy is the energy possessed by a particular system. Heat is the energy in transit. I don't particularly believe that definition, but to each their own. So think of it this way. Thermal energy is the host to particles in motion within an object or system, while heat is the form or method that thermal energy is transferred from one object to another. Using the same pot and stove, which now has water in it as an example, if you held your hand over the stove, you can feel the heat. If you put the pot back onto the stove, waited a few minutes, and then placed the thermometer inside of the inside of the pot, you would be witnessing the increased motion of particles, which leads to the increasing of temperature. Now let's dive right into these different methods that heat can be transferred. The three methods that heat is transferred by is conduction, convection, and radiation. Conduction refers to the transferring of heat between solids. Convection involves the transfer of heat through fluids, such as liquids or gases. And radiation is a method heat is transferred without constant contact between the heat source and heated object. All right, so as you can see, we have a few examples here. Let's go right into it. In our first example, we see that in conduction energy and heat is transferred by direct contact. Keyword being transferred. When you pick up a hot pot off the stove, heat is directly transmitted to your hand because of the difference in temperature. Our second image of convection shows a heated cup of water, eventually causing heat to rise. Using the same pot and water, imagine we put a lid on it. As the motion of the particles continue to increase, the temperature increases within the pot, causing the water to become less dense and rise. When removing the lid, water becomes exposed to a difference in temperature, typically a cooler temperature, causing the water to change into a gaseous state and rise, carrying the same thermal energy from inside the pot. You can feel the transfer through heat as the gas quickly rises and dissipates. A similar example could be when taking a hot shower and the mirror gets foggy. When you open the door, the cold air from outside the bathroom comes in, causing that gaseous, misty feel. Now, our last example is shown I'm sorry. The last photo shows thermal energy being transferred through radiation. You can feel the heat from the fire even though you are not touching it. Another example would be the sun. Although we feel the heat of the sun, there is no direct contact. This type of heat transfer uses electromagnetic waves. Another interesting fact is that radiation can travel through empty space at the speed of light. It does not require a medium, it does not require the exchange of mass, and it does not even require matter. Temperature, our last topic. All right. The temperature of an object or system is an estimated measurement of the thermal energy within. Remember that the size or type of object does not affect its temperature, only the motion of the particles is relevant. In the first definition, it states, temperature is defined as a measure of the average kinetic energy of the atoms or molecules in the system. It's basically the same thing. Kinetic energy, if you recall, has to do with the movement of particles. In my own words, I decided to write, temperature is a measure of the average heat or thermal energy in an object or system. Temperature does not depend on the size or type, and a commonly used device to measure temperature with is a thermometer. Thermometer, okay. Definition for a thermometer is an instrument for measuring and indicating temperature, typically one consisting of a narrow, hermetically sealed glass tube marked with graduations, and at both ends a bulb containing mercury or alcohol, which extends along the tube as it expands. Now, mercury is no longer used because patients were actually getting sick from mercury poisoning. An example of a few thermometers is the one in the middle, which is a laboratory thermometer. As you can see, the red liquid is mercury, and as the temperature changes, the liquid starts to rise. A second example is an oral thermometer, typically given to kids just to get their temperature. Our last example is a rectal thermometer. Now, I chose to include this type of thermometer because the history of it is quite elusive and somewhat unknown. Adding to the mystery, rectal thermometers are rarely used for temperature taking. It is seen as an invasive and humiliating process in today's society. While the scientific community agrees on the use of a rectal thermometer as the most accurate method in obtaining a person's core body temperature. So it kind of makes you wonder, something that socially we see as taboo, but medically has a lot of backing. By now, we should know that anything that can be measured will have a scale. We are going to discuss Celsius, Fahrenheit, and Kelvin. After this, we are going to compare the Fahrenheit and Celsius scale and the Celsius and Kelvin scale. The Celsius or centigrade scale identifies the freezing point of water at 0 degrees Celsius and its boiling point at 100 degrees Celsius. Celsius is the primary scale used in the modern form of the metric system, referred to as the International System of Units, or SI for short, and is the most widely accepted system of measurement on a global scale. So the Celsius was invented in 1742 by Swedish astronomer Anders Celsius. The actual term centigrade is derived from the Latin word centum, meaning 100, and gradus, meaning steps, which referred to the 100-degree interval between its points. So Celsius can be used to refer to a specific temperature on the Celsius scale and to indicate a temperature interval, which is the difference in time between two temperatures, and it can also indicate an uncertainty. Next, we have Fahrenheit. The Fahrenheit scale was invented in 1724 by German/Dutch physicist Daniel Gabriel Fahrenheit. The boiling point of water when using the Fahrenheit scale is 212 degrees Fahrenheit, while the freezing point is 32 degrees Fahrenheit. The Fahrenheit scale is almost unused across the world. It is the oldest scale for measuring temperature available, but still preferred over the Celsius scale in the United States. The US chose to abstain from the conversion to the standard system of measurement, the metric system, in 1975. In this comparison of the Fahrenheit and Celsius scale, oops, sorry about that. Had a little glitch there. All right, looking at this picture, we can compare them, and it would be common sense that the freezing point of water is an exact 0 degrees Celsius instead of 32 degrees Fahrenheit. Even the boiling point of water at 100 degrees on the Celsius scale, oh, there it is, would make more sense than the Fahrenheit scale using a very strange number like 212 degrees Fahrenheit as its boiling point. The Celsius scale is great for taking the temperature of water, but I feel the Fahrenheit scale applies to much bigger and important tasks. Looking at the ambient temperature of the Earth. The primary range of ambient temperature on our planet is from negative 20 degrees Fahrenheit to 110 degrees Fahrenheit, giving a 130 degree range for margin of error. On the Celsius scale, the range is from negative 28.8 degrees to 43.3 degrees Celsius. This results in a 72.1 degree range for error. Since the Fahrenheit scale has almost double the range for margin of error and a bigger scale, this allows a more exact measurement of temperature. The Kelvin scale is an absolute thermodynamic temperature scale thanks to its null point being absolute zero, or known as 0 Kelvin, which the third law of thermodynamics states it is impossible by any procedure, no matter how idealized, to reduce the temperature of any system to 0 temperature in a finite number of finite operations. Basically, everything stops or is frozen, in a sense, at a certain temperature. Since Thomson realized the exact value for absolute zero could never be found, he built his scale using the symbol K and defined absolute zero as 0 Kelvin. Proposed in 1848, the Kelvin scale is defined as a scale of temperature with absolute zero as 0 and the triple point of water at exactly 273.16 degrees. The Kelvin scale is named after British physicist William Thomson, aka Lord Kelvin or Baron Kelvin. The symbol for Kelvin is the letter K, and it is a base unit of temperature in the International System of Units, or SI for short. Although the Celsius and Kelvin scales may seem different, they are not. The main difference is the values for absolute zero. The Celsius scale defines absolute zero, which is the theoretical temperature that molecules of an object or system has the least energy, as negative 273 degrees Celsius. The Kelvin scale, being, quote, an absolute thermodynamic temperature scale, unquote, defines absolute zero with the symbol for Kelvin, the letter K. Remember, since the third law states for an object or system to reach this point, it is basically impossible, a value cannot be assigned for absolute zero. Now, looking at similarities, if you look, the difference between the freezing and boiling points of water for both scales is 100 degrees each. This simply means that the Kelvin has the same magnitude as the degree Celsius. Did you happen to know? As of 2017, only 4 countries, the United States, Belize, Palau, and the British territories of the Bahamas Islands and Grand Cayman Islands, are the only countries on the entire planet that still utilize the Fahrenheit scale. It was a pleasure, and I hope you enjoyed and learned something. I'll be taking questions now. Okay? Thank you very much.